As we begin hacking, we start by gathering information about our target, and we want to be subtle about it. That's where footprinting comes in. Footprinting is our first step in reconnaissance. We're looking on the internet. We're looking for traces and tracks of the target. We're looking around. We're not engaging them, but we're collecting as much information about all the stuff they leave, the footprints they leave behind, right? We're trying to gain knowledge of the target, their security posture. What do they have? Who do they have? What are physical or logical vulnerabilities, possibly? Let's get a high-level map of their network. Let's understand the human targets we might engage, or the potential servers and systems we might try to attack. Any information that might not seem immediately useful may still be relevant later. The types of things we're going to gather will include anything that would help us gain access to the target network. General company information, their mission, their services, their products, their activities, where they are, their contacts, email addresses, contact information, job roles, their internet presence, what domains do they have, what websites do they have, what online services do they offer, any IP addresses, network reachability, any documents that might have leaked out onto the internet, any login information, their overall security posture so we get a sense of how difficult they'll be to hack, what technologies do they use, and also where are they in the market. Market information, their profile, their assets, their financial information, their competitors. You can get footprinting from all over the place, but mostly it's somewhere on the internet. The company website, who is, search engines, job boards, people searches, social networking, social media, press releases that they put out, and specialized open source information tools, OSINT tools. Passive footprinting is the quietest. We're going to look through publicly available information. We'll use open source intelligence. We're not going to directly engage the target. We're just going to pick up on all their footprints that they left behind. Active footprinting, well, this is where we're going to engage the target, but we're going to do it in just normal, innocent, innocuous ways. We're trying not to arouse any suspicion, so active footprinting is not going to be a port scan. It's going to be more like visiting the website, like a normal visitor, a normal user. Engaging with people at a trade show or a conference or some kind of event or presentation. Stuff that would not arouse their suspicion. Stuff that the general public would just normally do. We would interact with them. We would go to their public servers. We would query their DNS server like we're doing normal business. We might do a trace route to their network. We might mirror or crawl their website. We would extract published information, published document metadata, and more on that soon. We'll do a little bit of social engineering, collect business cards, chat people up at public events, trade shows, but all of this would be normal stuff. It is not designed to arouse any suspicion at all. The footprinting process starts with, if they have a website, let's visit it. We can use search engines to get information about them, including news and press releases. We could use cached information from search engines, or go to places like archive.org to see information that they took down, but someone got a copy of it. We could use OSINT tools to automate our information gathering, get hidden information. We can do a lot of footprinting through social engineering, but remember, this is casual contact. We want to know names, job titles, personal information, email addresses, contact info, stuff that we can take advantage of later. We're trying to appear like it's normal business. We want to go unnoticed, look like potential customers. Techniques, just interaction at a trade show, at some kind of public event, or maybe at a coffee shop. We'll eavesdrop or shoulder surf or dumpster dive or impersonate people on network sites. We could also sign up for alerts and update monitoring. You can monitor a website for when they change their content. We would set alerts to notify us when that change happens, and we get the alerts via email or SMS. You would have to register with the website to do this, so you get Google alerts, Yahoo alerts, Twitter alerts, Giga alerts. It depends upon the service. Some OSINT tools will offer monitoring and alerts. And finally, we have this whole mass of stuff. What are we going to do with it? How will we use the results that we have gathered? You need to analyze all this stuff. What would be useful for your next moves? And remember, what might not seem useful now might become really useful later as you start to see connections and trends and you start to group things up. So small bits of data, don't discard them. Just keep them handy, but look for your next steps. Get a sense of their overall security posture. How much do they care about security? How easy might it be to break into them or to social engineer them? We're going to look for information that we can use. We're going to get a sense of, do they have IP addresses that we could scan? Do they have servers or services that we could scan? What do they have on the internet? What maybe IoT devices do they have that might be useful for a compromise? Are there people that we can social engineer? We need email addresses to phish, phone numbers to call so we can impersonate. Are there names and job roles to target? And also their physical presence. Do they have areas where we might be able to sneak in? Let's just take a look at like a overview picture of their facility. Okay, could we plant sniffing or snooping devices? Could we sit in the parking lot here because people go in and out of the front door here? We are also going to look for Wi-Fi signals, and if there aren't any, could we set some up? So these are the things that we want to think about when we first start hacking, when we start with footprinting. So these are the things we're going to think about when we first start hacking, when we start with footprinting. And now, on to the next topic. I use the term OSINT. Now let's take a look at what that really is. OSINT is open source intelligence, and there are many tools we can use. One of them is the OSINT framework. This is a search engine. It's a cybersecurity framework. It will get information from publicly available sources. It'll collect usernames and contacts and emails and public records, domain names, IPs, threat intelligence. OSINT framework actually expands out. It's very comprehensive. You can go to osintframework.com, and here's an example. You would just click one of these, which would expand out, then you click another, which expands out, or you click this one and it expands out, and you can keep on searching, and then you can select something to actually get information. Spies is another tool you can use. They use several tools, and they gather them into one full-service platform. You can go straight to their website, or preferably you write your own script or you use their website API. An API is an application programming interface. Now, that tells you a whole lot, right? What that really is it's a particular page on their website that is meant to interact with an application or a script. Usually you need to register with them to get an API key. So you would write a script, or you'd have an app or something that would then go and use the key to log in, as it were, really just to identify itself. And it would send queries using a particular language that that site requests. And they would say, okay, if you want to be able to ask certain questions of us, you have to formulate it in this way. And then your app, your script, would then query for information using the syntax that they require. That's what an API is. A lot of these sites have APIs that you can use that humans don't have to spend the time and the drudge work of looking for something that an app or script could get very quickly. Here's an example of spies. Then there's Maltego. Now, Maltego is a really popular tool. It finds relationships between people and IPs and groups and documents and sites, and it shows those relationships visually, so it's easy to follow and sort of track the whole thing. It's used by law enforcement. I have a buddy who works for a cybersecurity firm. He uses it. They've used it to track people who've launched denial of service campaigns. It was actually used for health during COVID. It was used to track, okay, who went where, visited what hospitals, what tourists were going to different places, to track sort of the movement and development of the virus. So Maltego, very, very popular. Kali has a simple version of it, and you can pay for more complex, with more greater features. Here's an example of Maltego, and you can see how you have one thing which leads to the next, which leads to the next. So it shows how different people are related, where they visited, what documents they've opened, what they've published, what they've put out on the internet, and who they're related to. Then there's my personal favorite, Shodan. Shodan.io is a search engine for things on the internet. You can find IoT stuff on the internet. You can find baby monitors and cameras and routers and servers, and you can find satellites and water treatment facilities and traffic light systems and prison payphones and nuclear power plants. I'll show you in some of our activities. It's astounding what you can locate. Anything that allows itself to be published on the internet, I mean, like Ring cameras and anything that you could potentially connect to via your phone or whatever across the internet. If it's connectable across the internet, Shodan has indexed it, and then we can look at it. With Shodan, you can get a free version, but if you want to really dig deep, you need to pay them for a subscription. Here are just some examples. I mean, these are just insane. Okay, so this is some data center. This is the inside of somebody's storage facility. This is really disturbing. This is the inside of someone's living room, someone's baby room. This, I think, turned out to be like the waiting room in a small clinic. Here's some office. I mean, it's really insane what you can see, and they'll be in real time. And one of the things that just blows my mind is if it's a camera, and whoever owns the camera, whoever put it up, doesn't like change passwords, you can sometimes move the camera, you can pan, tilt, zoom. It's just really amazing stuff. I mean, folks use Shodan to identify their stuff, but you can find other people's stuff. Then there's a competitor to Shodan called Census.io. It too will discover IoT internet-facing devices, and it even offers a cloud-based dashboard. There's the Harvester. This will gather email addresses, subdomains, host names, employee names, open ports, banners from different public sources like different websites, PGP key servers. It also will search the Shodan database. It's written in Python. In order to really take advantage of it, you'll need an API key from the various sources that it queries. Here's an example of using the Harvester. So we'll check hackthisSite.org, and then this is what it found. Then we have Sublister. This is really useful in trying to find child domains, subdomains of a larger parent organization. And the reason why you want that is, the main company, the main website is probably well protected, lots of resources, good security. But those child organizations, like smaller military units or specific sales regions of a bigger company or different divisions or departments, they're usually run by smaller organizations that have some independence and autonomy, at least in their administration, but they probably have internal connectivity. These smaller domains will have little websites that usually aren't as well protected because they don't have the resources or the technical skill that the big parent company would have. And if you can break into that down there, you might find a way to then internally get up to the bigger domain. So sublister is a good way of revealing and finding those subdomains, those child domains. And here's an example of sublister in Kali. Then there's Recon-ng, and we use that for, again, sorry. Then there's Recon-ng, and we use this for full-featured web reconnaissance. They've got a lot of modules. It's written in Python, and again, it searches all these different things. You're probably going to need to get API keys for the various sources that it searches. Here's an example here. So we were looking at domain vulnerabilities here. We were checking cisco.com, and we found different hosts and examples with, say, possible cross-site scripting vulnerabilities or redirect vulnerabilities. So this is just a quick snapshot of Recon-ng's output. Then there's InSpy. This searches LinkedIn. You can install it on Kali. It will search LinkedIn for employees for particular organizations. So like, here's an example here. We're going to use InSpy, and we want to get word lists and titles from Google. Or this one's for technology. So InSpy TechSpy. We'll use the word Cisco to target the networking company Cisco. And so we want to look for tech list. Some examples of InSpy. Here is an example of actually using it. We're crawling to look for employees, and we found their emails. There's also Android InSpy. Now that is an Android app that looks at Instagram likes and follows those, follows the likes and the comments. If you want to automate crawling a website, use something like Spiderfoot. When you spider a website, you're doing an automatic crawl of that website to look for stuff. So this is an automation tool. It's written in Python, and there is also a cloud-hosted version. You can get a subscription. Here's an example of Spiderfoot. It's crawling, and then you can click things to open them up and take a look at what they have. Then there's the OSR framework. This has a whole bunch of tools, libraries, for open source intelligence. It'll do name searches and DNS lookups and look for information leaks. It'll search the deep web. Now, don't mistake the deep web for the dark web, okay? The deep web is all of those sites out there that are not indexed by Google. They're not really meant for the general public. They're meant for students or associates or partners or vendors or people that you work with or do business with. You don't necessarily want Google advertising to the whole world, but you want to allow people to use the internet to get to stuff. That's the deep web, and there's a huge amount of deep web out there, and then there's the stuff that we search for using Google and the other search engines. So the OSR framework can do all of these things, and you can extract regular expressions, which is a certain syntax for searching or for specifying strings and other types of text. You can also extract what we call metadata, or data about data. So if you've ever written a document or taken a picture and it shows the time and the date, the timestamp, who owns it, who created it, the type of document or that it is. That's metadata. There's a lot of useful information to be found from metadata because this information could be hidden inside of a Word doc, an Office file, a PDF. You can use it to perform social engineering. Like, I can find out the name of someone who publishes a lot of stuff. Maybe I can find out information about them just by looking at the metadata of the documents they put out. So there are a variety of tools for metadata extraction. MetaGoofle, Extract Metadata, Foca, a bunch of them. Some of them use online, some of them you can use by downloading and installing an app. Here's an example of Foca. You can search a site and then it'll find all the documents from that site and then it'll look at the metadata and give you information that it finds. MetaGoofle. It will get metadata from publicly available documents like PDFs and Office docs, and it uses Google Hacks to find that information in tags. And it'll generate a report, usernames, email addresses, software versions, server names, that kind of thing. Here's an example of MetaGoofle. So this is open source intelligence, OSINT. This is what we use when we are doing reconnaissance, particularly passive reconnaissance. And now, on to the next topic. There's another really cool tool you can use in Kali Linux called the Open Source Research Framework, the OSR framework. You have to go and install it, but it's easy. So what we're going to do is we're just going to download and install OSR framework in Kali. And it has several different tools. They're all Python scripts. One, you can search across a huge number of platforms to see if a username exists. Now, sometimes you will get false positives. We'll see that. Or you can specify a couple of usernames and then specify the platforms. And there are many platforms. If you don't specify, it'll do them all. And then we could search if there's any email that has this string in the email name. Or we can search across everything to see if just this string, whatever it is, in quotes, exists in any way, shape, or form. And what it does, like I said, is open source intelligence, where it just looks online across all these different platforms like Yahoo and Twitter and Facebook and YouTube and LinkedIn and a whole bunch of different things to see if it can find these strings that you specify. In this way, you're looking for usernames and emails and other possible things. So we're just going to take a look at it right now. I'm going to just move this over so we can see. It does not take long actually to install. So we apt, it's actually apt-get, but apt is good enough. Apt update and apt tac-y install yes, install OSR framework. Now, I've already installed it, but I'm just going to let it rip so you can see it. It only takes a moment. And then what we're going to do, so mine is already set and ready. We're going to just do a usify Python script looking for the name Mudharma, the username Mudharma. So we're going to say usify, and I recommend that you try this on your own usernames. I encourage you to try all sorts of things. Mudharma, that's just a pet username that I have when I teach, and I'm pressing enter. And it will go out and it'll start searching. Okay, so we have some results here. Let's just expand this a bit so we can just kind of see what we've got. Now, some of these may be false positives. Like I created this user called Mudharma, and I just use it for teaching. I have never set Mudharma up with Saraha, which I have no idea what that is, or BuzzNet. I don't remember ever giving Mu a Twitter account, or Streak Game, or Carding Hispano. Of course, that doesn't mean somebody else hasn't done it as well. So here are the results that we found on several different platforms for this particular user. Now we're going to try another one here. Let's try one for CEH user and Susie Q. And let's specify just Twitter, Facebook, YouTube. So notice the TAC N for the name, TAC P for the platform. And I'm just going to bring it over here so we can see it. And it even says, did you have any issues? Is there a false positive? You can report issues to us here. And we're not going to obviously bother with that. So let's usify TAC Python, TAC PY, TAC N, CEH, and again, you should be trying this just with your own stuff. Make up different things, look for yourself, look for people you know. So we're going Twitter. What did we say we were going to do? Twitter, Facebook, YouTube. Facebook, YouTube. And let's just let this rip. And it's going to look for both CEH user and Susie Q. And so we have some hits. And we can see that, if we scroll up here, that Susie Q showed up on YouTube, probably no surprises there, CEH user on Facebook and Twitter, And Susie Q also showed up on Facebook and Twitter. Okay, now how about one more here? Well, we'll do two more. Let's see if there's any email that has L. Torvalds, like for Linus Torvalds, like the guy who invented the Linux kernel. Let's see if there's any emails that has this string in the name. So we're going to try that one. Let's mail phi.py tack in L. Torvalds and press enter. We'll see if any, oh, some have already come up. Oh, no, it's searching to see if any of these have been leaked out. See if there are any email addresses here, because obviously, if we're targeting people, we want to find out what their email addresses are. Again, this doesn't take too long, so what I'm going to do is pause the recording, and as soon as we have some results, we're going to go take a look. Okay, so we can see that it did show up in Rocket Mail. And so we saw that via Tumblr. All right, so there was a hit here. And we can scroll back and we can see how it was trying various possible sources. And you go through the whole thing, and here was one. It found one in Rocket Mail. And then all these others were attempts, but until we see the green, they didn't actually show anything up. And so this is interesting. It says, Mailify will use haveibeenpwned.com to find leaked emails. If you've never gone to haveibeenpwned.com, it's kind of fun to do that. Just go to this address here, haveibeenpwned.com, and put in your email address and see if it has ever shown up where it was leaked out to the general public in different ways. And it's rather a fun thing to check out. Okay, so we found a hit for email, and we can also just search all of the possible searches just for a string, whatever that string is. Whether it is, some kind of text or a name or whatever, we're going to query all platforms just for this string, whatever the string is. We're putting it in quotes. Now, sometimes when you put in different kinds of strings, I found that the script blows up sometimes, but let's give it a shot, see if it works. So we're going to search pi tac q to do a query and put in something here. Put in this string to see if we can get something out of it. So let me just bring this over here so we can see. Let's search phi, not search if phi, search phi.py tac q, in quotes, Dookie 2000 CA, close quote, press enter, see if it shows up just anywhere. Notice we're looking Facebook, GitHub, Instagram, Twitter, da-da-da-da-da. Yes, we found a hit in Twitter. And if we scroll back up, we can see the various platforms that it searched, and then it found a hit. So that is using the open source intelligence research framework, the OSR framework in Linux. Let's do a little OSINT with the harvester. I'm logged into Kali as the Kali user. Just going to come up to Apps in the upper left, click that. Go to Information Gathering, OSINT Analysis, click that, and come down to the harvester. Now notice that it's spelled one word, all lowercase, and I'm going to make a comment in just a moment. Click that. When it opens up, let me just scroll back a little bit here. It opens to the new version, which has a capital H. Don't forget that in Linux, everything is case sensitive. When the tool opens, it opens the help files. We can see the basic user, the harvester, and then one thing you have to put in at least is tac small d, and then the name of the domain, such as eccouncil.org. Then you can also limit your results and use particular DNS and get screenshots, indicate the file name for output, and the one that's especially interesting is the source. Let's scroll down there, take a look. The harvester has been through a number of renovations, iterations. They used to have far more sources than this. You'll notice now that there's no Google and there's no LinkedIn. It will look for LinkedIn links, but it won't go to LinkedIn per se. But it does have VirusTotal and Yahoo and DuckDuckGo and HackerTarget and Baidu and a bunch of others. We're just going to do a simple search on Easy Counsel. So the Harvester with a capital H, Harvester, tech, small d, easycounsel.org, easycounsel.org, and we'll limit to 500 results, and our source will be all of these. Now, not all of these will work, but we're just going to try them. Press enter. You can see that it says, hey, I need API keys for some of these. That's fine. We'll take a look at getting API keys a little bit later. And it might also have some things like I can't connect to this or some error with that, but that's fine. It's searching the various sources. It'll take a couple minutes, so when it's done, we'll come back. It's done. Let's scroll back and take a look at our results. There are a ton of hosts here. Back. Oh, some longer URLs. All right. This stuff up here is status on the search, starting with 5 autonomous system numbers, which if we did lookups on those would tell us network IP blocks, as well as possibly we could find routes to them. Interesting URLs, 53, not just normal hosts, but looks like there are some blogs, privacy policy. We'll scroll down here. Cybersecurity Awareness Month, special offers. As we scroll down, we could follow one of these and click it, just out of curiosity here. How about this one? I'm picking them randomly. I'm just going to right-click this highlighted or this underlined one, and I'm just going to open the link. Should open Firefox to it. CodeRedMarketing.easycounsel.org. Hard to tell if this is a host or a subdomain. Probably a host of easycounsel.org would be my guess. I wonder if it is well secured or not. That would be interesting. Has some little pop-ups and it's trying to sell us some stuff. Let's go back to our results. Go down farther. Well, some of these are pretty lengthy. I wonder, how about this one? Let me just try to open this one. Yeah, another one of those. Okay. Continuing on down here. What's this? Something Facebook. CyberSecurity Skill Builder. Oh, what's this one? Let's just try it. Okay, yet another. Continuing on. The interesting part about all of this is these are either hosts or they are, well, they're URLs, but like iClass.easycounsel.org, probably a host. Code Red Marketing, probably a host. Payment, no, this would be interesting. Invoice link, iLabs, login. Let's follow the iLabs login. Let's see that one. Okay, here's where we can try a little SQL injection, huh? Okay, let's go back. What about this payment.easycounsel.org? That might be interesting. Right-click this one. Let's go to this one. Invoice link. Huh. Invoice payment app. Well, seems to be a transient thing. We don't actually see anything now. Can we just right-click this and look at the page source? Is there anything? Oh, no, nothing. There's nothing to this page. All right. Continuing on. So there's a ton of stuff. Wow, look at this gigantic thing. As I mouse over this whole line, all these lines, 5, 6 lines, 7 lines. Right-click this one. What's this? Okay, whatever. URL 7581. I wonder if that was dynamically built. Right-click. Let's just, can't even choose the page source. Oh, is this like a 1 pixel? Mouse over, I don't see anything. Inspect. No, not much to this. Okay, well, that was kind of disappointing. That was old. No LinkedIn links found, but 97 IP addresses found. Oh, this is good. So this means we could find routes to these various hosts. All right, scrolling down a little bit more. Lots of IPs, even a few IPv6s. And then actual hosts with their IP addresses. What would be fun is to go down the line here and see which ones look like potential targets. Autodiscover.ecouncil.org. Autodiscover is, in some cases, the default name of the Microsoft Exchange webmail front end that is used to kind of discover where your particular webmail server is. Backend dash code red, blog, campaign, all very, very interesting stuff. Checkout.ecouncil.org, Well, this would be fun to just kind of take a look at some of these in greater detail. Some of these are beta tests. Beta tests might be not as well secured. They might just be there for development and not as secured as, say, a public-facing production. DevCert, ebooks, lots of interesting stuff. Scrolling down a little bit farther, loads and loads and loads. It looks like the harvester for ecouncil.org gave us a ton of hosts with their IPs and URLs that looked different and autonomous system numbers. That's quite a bit of stuff. Okay, let's move on. Previously, I talked about adding API keys to the harvester so we can do some more research. I have created an account on both Shodan. Just go to shodan.io and create an account. You register and then you are ready to log in. I've also created one on VirusTotal. I'm going to log in to both of these and get an API key from each of these. The whole purpose of an API key is to identify your client app, whatever it is, browser, the harvester, some mobile app, whatever it is, to identify your client app to a website so that the app can directly talk to the website and ask for information and exchange information without the user having to click anything. I'm going to log into Shodan. And in Shodan, if I go to Account and I go to Overview, I can see the overview here, and I can see my API key right here, and it's just a long string. Let me just copy this. I'll save the Shodan API key to a text file so I have it handy. And now I'm coming over to VirusTotal to log in. I'm going to go grab my API key from there. Just come up to the profile, click that, go to API key, click that, and there it is. If you want to see it, click the little viewer thing, and you can see it. Of course, I'm hiding mine. I'm copying it, and I'm going to save it in the text file as well. Now that we have our two API keys, let's open up the text file that we need to edit. Let's just browse the GUI so I can show you, but then we'll have to use the command prompt to actually do the editing, and I'll explain why in a moment. Open up File System, go to Etsy, ETC, open that up, scroll down and find the harvester, there it is, open that up, and this one right here, api-keys.yaml, that's what we need to edit. But we can't just right-click and edit with Mousepad because we need to open Mousepad or Nano or Pico or whatever text editor you're going to use. We need to open it with root privilege. So just knowing that this is what we're going after, I'm just going to minimize this. I'm going to open a terminal, and I'm going to sudo nano or mousepad, maybe mousepad. I love mousepad. etc, the harvester, and then what was it? API-keys.eml. So let's run this in sudo privilege. Enter. The password is Kali. Enter. And here it is. And it's warning us, you're using the root account, da 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 da. Yeah, we know that. We need to. You can see that this little text file here is just an empty file waiting for us to put the keys in. You could put in a key for GitHub or other things. Just go down. We have a key for Shodan and VirusTotal. Let's go grab the key off of our text editor for Shodan. Get this, copy it. Now, the secret that a lot of folks don't realize is you need to put a space in here. One little space. One space. Okay. Now you can paste it in. Let's do the same for VirusTotal. Control-C. One little space. And then right-click and paste. All right, I have my two keys in here. Let's save this up. File, save. And then close it. Close this. If we go back into our file system, and we go to Etsy, and we go to the harvester, and we see API-keys.yml, and we right-click and open with mousepad, we can see the keys are in there. Okay, close. Now that we have our two API keys stored in our config file for the harvester, let's run it again. We'll open up the harvester, and we'll make the query a little bit shorter this time. Now this time we're going to also query Shodan to see if EC Council has any IoT type devices on the internet. Does it have any cameras or other types of devices? Let's check that out. And let's just limit our source to, how about DuckDuckGo? Or we could choose Bing or something like that. I'm curious about DuckDuckGo. I like DuckDuckGo because they truly don't track you. All right, the harvester. And the domain is eccouncil.org. And we're going to limit to 500 results. We're going to tac S, meaning do a Shodan search. If you've used the harvester before in the past, you'll notice that this syntax is really different. Like the tac small s used to mean something completely different. Okay, so we're going to tac small s. We don't have to say Shodan. And then let's see. Let's have our source, tac B, be DuckDuckGo. And let's F to output to a file. You just give the name of the file. It will save an XML file and a JSON file. I do not believe that these outputs will give all the details that we see on the console, but let's find out. Why don't we call this results? Ready? Hit it. It will, of course, take a moment, so when it's done, we'll come back. Well, that was quick. Scrolling back, well, I do see JSON output here, and all these ports here, now that's a Shodan result. Okay, cool. So this is a Cloudflare server, but we had access denied, and it listens on these ports. That is definitely from Shodan. What else do we have? Scroll back. Okay. Didn't find any IPs via DuckDuckGo, didn't find any emails, did find some hosts. Cool. Let's go take a look at the results. Just going to open up Home, and we should see it right here in our profile. Going to go down and find results.xml, open that up. And yeah, it looks like it only shows hosts and IPs. It does not show the Shodan stuff. Okay, that's fine. How about if we look at the JSON file? Oh, and it is not formatted. I mean, JSON should be in this nice laid out format, but it's all here. Okay, so that's using API keys to get additional results from the harvester. Now let's move on to the next topic. We will use FOCA to find metadata in online documents. What we're going to do is we need to create a project. So we can see there's no project at the moment. So you come up to project, you click that, and you create a new project. And you call it whatever you like. We're going to scan ecouncil.org. And so the website is www.ecouncil.org. We're going to see if we find anything. If it finds mirrors that are like Akamai's or something like that, it will add those alternative domains. You also can add alternative domains if you want. So let's create the project. And where are we going to save the project? Well, I created a folder called Projects in FOCA. You can create something or put it anywhere you like. Click Save, and the project is saved successfully. You'll notice here that it's going to look for all these different kinds of documents. They're mostly Office documents, but there's PDFs also, which goes along with the Office documents. And then there's some SVGs and a couple of other things. So it's going to search there. So what we're going to do is first we're going to click Search All, and then we're going to tell it to start because it's a little funky the way it goes. So we click Search All. Won't take too long for this to finish up searching the various search engines. And it says, www.ecouncil.org also belongs to a net range of Akamai technologies. Akamai is a mirroring company, so a lot of websites use them as their load balancing mirror. So I just click OK. That's fine. Just keep going. The search itself is done. And so now what we're going to do is we're just going to expand a little bit here. Right now we don't have much of anything. So it's in the network, it can look for clients and servers, and it can look for domains and subdomains, and it can look for roles, HTTP, FTP, DNS, SSH, Telnet, VPN type roles. It can look for vulnerabilities possibly, and it can look for metadata. So what we're going to do is we're going to come up to network here. We're going to click network, and we're going to ask it to start. And we're going to do a web search, and we're going to do other kinds of things, and we're searching Google Web. We're going to do DNS search, we're going to do dictionary searches, and IP Bing searches, Shodan, Robtex searches, just so that we have sort of a broader search range. So I have clicked Network under this project, and I click Start. Now this one's going to take a while, because it's going to basically just go down the line here and try everything. And whatever it finds, we'll be able to browse. But it will take a while, so I'm going to just pause the video and I'm going to come back when this is done. Okay, we're back and we can see that search with all the subdomains for www.ecouncil.org is finished. So let's see what there is to find. So going down the network, we can see that there are 5 servers. And if we expand that, they're in the 104 subnet, 104.16, and we can see that there is ecouncil.org 104.16.193.17. Let me just expand this a little bit here so we can see a little better. And we can see there's another one in the 194 subnet, and the 195 subnet, and the 196, and the 197 subnet. We don't have any other information about clients or servers. We can see that Akamai was obviously a mirror. There's ecouncil.org, and so when we click that, we can see that there is a domain and an IP address. And related domains, not only www.ecouncil.org, but just ecouncil.org and dictionary.com. Were there any roles? Any Active Directory? I wouldn't expect it. Any DNS? I wouldn't expect that. FTP? Hard to say. But I do expect to see HTTP, and sure enough, you have these servers here running HTTP. And you can see that they have CNAMEs, basically. So even though you have www.eccouncil.org, you have other names that fit that. So you have CNAMEs to the same IP address. When I click them, these are all just load balancing, obviously. Anyone running HTTPS, don't know. Instant messaging, Kerberos, LDAP, probably nothing. Don't see anything to expand here. Are there any vulnerabilities that were discovered? In the meantime, when I look down here, I can see that Shodan was attempting to make connections to them. And we found stuff in Bing Web. If I look down here in vulnerabilities, I'm just going to click through these and see if there are any discovered vulnerabilities. Now remember, this thing is not a vulnerability scanner. It's finding the vulnerabilities only because it has searched files, not because it has actually scanned the server or any of the servers. So none of the files revealed anything that might have told us anything. Any summary on the metadata down here? So I can see, was there anything about users? They didn't find any users, printers, folders, software, emails. Not really. But we did at least find some things. So I suggest that you try this yourself. Create a new project and pick some domain, comptia.org or whatever you like, something preferably you don't have to log into, something that there would be a lot of information available on the web about, and see what you can turn up. And realize it's going to take a while for this thing to complete its scans. So once you create the scan, you tell it to scan now, then you come over to the network and you tell it to start, and it'll do all these different kinds of searches. And then go and have something to eat, and then come back and check it out. So that is doing some OSINT using FOCA. You probably use Google to look stuff up, but did you know you can use advanced search techniques? Let's talk about Google hacking and Google dorking. Funny name, I know. Google hacking means we're going to use specialized searches. We're going to look for unusual information, sites that could link back to a target, or information about their partners or suppliers or vendors, or error messages that might give us a clue on how to hack, or files that might contain passwords, sensitive directories, login portals, or vulnerabilities, software version information, web app source code. All of this could give us a way in. You could just do an advanced Google search, and you could put in certain words. You could say find all the words, or this exact phrase, or any of these words, or none of these words, or you can just put in whatever details you want. You can also search for images in the same way. Find all the words that have to do with the image, looking at the metadata. If you're wondering how to use this stuff, do a search for the Google Guide, and they will explain to you right here. You can see how to do all these different things, and just follow the links and get a tutorial on it. Now here's my favorite. Google dorking, Google dorks. A dork, in this case, is using a search string, and a string is just a string of text, using a search string with advanced what we call operators. This will help you find information that would take you forever to search for, that would be not readily available in a normal search. You can find vulnerabilities in files, and passwords, and email lists, and log files, and live camera feeds, lots of stuff just by doing Google dorking. But you need to know what the dorks are. It's an easy way of hacking. So let's take a look at this. These are the so-called operators. These are the things that go first, like in title. I want to find strings of text that are in the title of a page, or find all of the terms that I list in the title of a page, or in the URL of a page, or restrict the search to a particular site or a particular file type, or search for links to a site, or show me Google's cache. Google does keep cached copies of popular lookups. Or display summary information. So here's an example. In title, your text, well, probably not your text, but whatever you want to put in. So the title of the page would be something specific. All in text contact. Or in URL, news.php, ID equals. So we can look at all these different things like cite or file type. We only want PDF with cryptography. Or we want links to example.com, or we want cache to yahoo.com, or we want info about a particular site. These are some examples here. Now, keep in mind that you can even get fancier. You can specify operators like or and, or quotes, exact match. Or you could have a dash in front, meaning I don't want that, or a wildcard, or you can group things. So we could just say, all right, Google or Bing or DuckDuckGo. Samsung and Apple, or Google Dorks Explained, which means it has to be that exactly. It can't just be just Google or explained. It has to be that phrase exactly. Or we want to exclude something. Give us information about Linux, but not from Wikipedia. And then we could have like wildcards. Username, whatever, password. And we can group them. We could say dorks or dorking or hacking and explained or tutorial or guide, meaning give us a tutorial or a guide or an explanation of dorks or dorking or hacking. So these are the examples of the Google Dork operators. So here's some examples here. I would like live feeds from a particular camera type, the access camera. So I would say in title. And you might say, I don't know what this is going to be. Well, I happen to know that Access style cameras, that particular brand, will on their camera web pages have this title exactly: live view / access. I mean, that's how they title the pages that you see when you go to the camera. And we could say and see this pipe? This pipe here in general means or. Or in the URL, we want video.mjpg, timestamp. And you might say, gee, I don't know what these are. But when you do learn about the things you're targeting, you'll go, oh yeah, I happen to know that this particular kind of camera always titles their web pages like this. Here's one where we're just looking for Excel files that have email lists. So file type has to be Excel. In the URL, it's going to be email.xls or xlsx or something like that. This one, we're looking for log files that might contain passwords and corresponding emails. So the file type is log. And then in the text has to be the word password. In the text also can be at gmail.com or at yahoo.com or at hotmail.com or whatever one you want to put in. Let's look for FTP servers that might contain sensitive information. So let's find index of, which is often the main thing you see when you go to an FTP site and you look at the directory itself, or FTP in the URL. Let's return results that match accounting from target.com, but not from marketing.target.com. So we want to go to the site target.com, but not the site marketing.target.com, and it has to have something to do with accounting. Or how about pages that might be vulnerable to SQL injection attacks? In the URL, we want to see PHP question ID. And in the text, we want to see error and SQL. We want to have reports about vulnerabilities from systems that have been scanned. So the title has to say report, and it can be Nessus or Qualsys, and the file type has to be a PDF. Or let's see about exposed SQL databases, including usernames and passwords. So index of and dump.sql. You can get creative. If you want to see what other people have put together, what dorks people have put together, go to the Google Hacking Database. It's run by exploitdb.com. You can find stuff that people have already tried. You can find the most popular dorks here. So like, you can do a search, and these are the most popular dorks, and they'll tell you files containing juicy info. Here's the person who created it. And There are so many of these that are shared. So if you're like, I'm kind of scared, I don't know how to do the dorks properly, go and find other stuff that people have done, use them. So that is advanced Google hacking. And now, on to the next topic. Let's do a little Google hacking. Now, you could indeed put in your own Google hacking search terms here, your own Google dorks, or we can go to the Google hacking database where other people have written some really nice ones for you. Let's check that out. Google hacking database. We'll go there. It's run by exploitdb.com. You can see that there are a bunch already here. Files containing juicy info, pages containing login portals. Scroll down a little bit more. There are so many. Look at this. There are like 7,000 of them. Online devices, real-time IP camera monitoring system. Oh, that would be interesting. Let's see here. Vulnerable files. Let's just keep going. I mean, heck, let's use someone else's good work here. Vulnerable servers, vulnerable files. There are 490 of these pages. Wow, really cool stuff. I'm just going to pick one. Screenshot.jpg. Hope we don't get back something that we'll have to censor here. Let's go there. You can see that they actually give you the dork if you want to just paste it in yourself like that. That's so nice of them. Well, let's do that. Let's put in the dork right here. Let's just copy the dork. Whoever came up with the idea of Google Dork, where did that name come from? So funny. Let's open a new browser and let's paste and search. Alrighty here. Images of media. Okay. Hope it's nothing's going to get us in trouble. Click this one. Got anything good? Let's see. These are login screenshots. Let's try another Google Dork here. Site.gov.in. Files containing juicy info. Let's go. Let's copy the dork. Control C. Let's go over. Let's paste it in here. Let's go. Index. Now we're talking. Let's go take a look. Parent directory. Okay, well, no files right here. But what about, is there another one? Assets. Let's check out this. Access denied. Can't imagine. Let's keep going down here. Try this one. We have some flash files and videos here. I'm kind of scared to just play that. Let's try another one. Let's go back to the beginning here. What was that? Web server detection, footholds, admin panel, site gov. Let's try that. In URL, admin panel, site, gov, whatever. Let's try that dork. Department of Personnel. Let's click this. It can get pretty fun, you know. Administration login. Well, we could waste a lot of time messing around with this. What's so fun about Google dorking and Google hacking is, yes, you can write your own, but you can also just use things that, oh, wait a second. Sorry, I just had my squirrel moment. Spreadsheets. In URL, admin, file type, XLS, spreadsheet. Oh, I have to. Let's get this dork. Let's see what we have. Squirrel moment. Give me admin spreadsheets right now. Okay, don't care about that. Let's go. Let's open it up. Oh, okay, so These are department budgets. Yeah, that's interesting. Why don't we see if there's anything about passwords? Password. Oh, in-text password. Pastebin, admin password. Oh, let's go there right now. Okay, so ever go to pastebin.com? Let's see if we can get admin passwords here. Let's check out that dork. Guest user, pastebin.com. Admin password for website. I wonder. Huh. I wonder. Let's go there. Wow. Wow. I have already blanked this out, so you cannot read the guy's username and password. We could have a whole lot of fun looking up stuff. Yeah. You can let your imagination run wild here. Someone has probably written already whatever you're looking for. We have 7,341 existing dorks that probably include all sorts of things. You could go crazy here. I'm going to let you enjoy this, see what kind of trouble you can get into. Remember, you are an ethical hacker. Your job is to heal, not to hurt. With that, let us move on to the next topic. One of the first things you'll do in footprinting is to perform a whois search. Now let's see what that's all about. To understand whois, we need to first look at the Internet authorities. When you register a domain name, it gets put into a database. And the registration, depending upon what you are, where you are, is handled by a different authority. At the very top is the Internet Corporation for Assigned Names and Numbers, ICANN. They're a non-profit, not-for-profit, public benefit corporation. They're dedicated to keeping the Internet secure and stable and interoperable. So they're responsible for specifying domain names and autonomous system numbers. When you're a big organization, not just an ISP, but also an organization that has like 50,000 nodes, you can have your own autonomous system number, which makes you a heavy hitter on the internet. A department within ICANN is IANA, the Internet Assigned Number Authority. These are the ones that will maintain a central repository for Internet standards, and they're the ones who will verify and update changes to the top-level domains, the TLDs, like .com, .mil, .net, .org, .uk, .biz, .info, all of those. Then there's the Internet Engineering Task Force, the IETF. They're an open standards organization, and they develop and promote voluntary Internet standards, especially if they're related to IP. The regional Internet registries, or RERs, these are governing bodies for a specific area in the world. They're responsible for controlling IP address distribution and domain name registration for their particular operating region. Now, what regions do we have? We've got the one for the Americas, ARIN. We've got Asia Pacific, APNIC. There's AFRINIC for Africa and the Indian Ocean. There's RIPNIC, which is for mostly Europe and the Middle East. And then there's LACNIC for Latin America and the Caribbeans. So you can see the different RERs here. So what is whois? Now, a lot of people think that it's actually a database. It's not a database per se. Whois is actually a protocol for querying a database and getting responses. So when I say protocol, I don't mean like TCP or IP. I mean, however, a set of rules for querying and getting responses, which makes it a protocol. You use whois to query databases that will store registered users or assignees of an internet resource, like IP address blocks, domain names, autonomous system numbers. The protocol will get database information in a human-readable format. And of course, it's widely available for public use. According to DomainNamestat.com, there are currently 13.7 billion Whois records, 700 million active domain names right now, and over 2,800 top level domains or country code top level domains. CC country codes like UK and TV, and TV is actually a country code, or CN for China, or JN. So these are top level country codes. So who maintains the Whois database? Well, there's no single database. Instead, there are two kinds of organizations that each maintain their own respective Whois database. There are the registrars. These are the companies that allow you, as a customer, to register a domain name. They are accredited by ICANN and they're certified to sell domain names. And they'll have resellers underneath them that also sell. They're responsible for those resellers for whatever their domain is, as well as themselves. Then there are the registries. These are the organizations that maintain records for the top-level domains, like com and net and org and UK and such. So ICANN, which is like overall, right, it requires that all these name registrations are accurate. They stay accurate for the lifetime of that registration. So when we saw here that there are 700 million active domain names, 13.7 billion Whois records, these 700 million active domain names, their information needs to stay accurate for the lifetime of the registration. When you do a Whois lookup, you are querying the database of that registrar registry. You're querying it for information about that domain registration. You can get the domain name, who's the owner, the details, the DNS servers that service it, any IP network blocks, autonomous system numbers if they exist. When was this registration created? When will it expire? When was it last updated? And it's really good for both ethical and unethical purposes. But I have to tell you, and you've probably discovered this yourself, that Whois is not as effective for hacking as it once was, because so many smaller organizations and individuals now hide behind whoever they register with. So instead of seeing the person and the real contact info of that actual domain, you'll just see GoDaddy or whoever the registry is. So you may or may not get the information that you want. There are a ton of Whois lookup tools. You can go straight to whois.com. You can go to Domain Name Stat. In fact, you can request that they let you download their entire compiled Whois database, probably by registry, and they'll probably sell it to you for their trouble. And there are all sorts of tools. There are tools built into Kali. There are tools that you can download apps. There are websites, all kinds of Whois lookup tools. Here are just a few examples of mobile apps for Whois lookup. So that is using Whois, which is one of the first things we've always done when we've started our footprinting. And now, on to the next topic. Let's do a little Whois research. We're going to check just a few sites, see what we can get just by doing a little OSINT. The first one is www.whois.com. We can either search for the availability of a domain name if we're interested in purchasing one, or we can go straight up to the Whois tool. Let's do that. Click Whois. I'm interested in knowing some information. They even give you a few examples right here. I'd like to check out eccouncil.org, the very people who bring us the Certified Ethical Hacker certification. Let's search for eccouncil.org. Now, a lot of organizations hide behind whoever they register with. Let's see if EC Council does that. They register with Network Solutions. They first registered in 2001. Okay, and as we scroll down here, a lot of information here redacted for privacy, yes. So they're hiding behind their registrar. Okay, what about CompTIA? Let's try those folks. CompTIA.org. All right, let's try them. They registered with GoDaddy in 1985. Okay, and yeah, they're hiding as well. How about Microsoft? Let's try those folks. Microsoft.com. Press enter. Okay. They registered back in 1991. I see they're hosting their own DNS servers in their Azure cloud. And here we're getting actual addresses, phone number, fax. Fax? Does anyone still use fax? So this is the contact information of the registrant, Microsoft, and their administrative contact is the same. Looks like the email address is different. And their technical contact information is the same, although the email is different here. Raw who is data. We can see when they registered. And some email addresses here. Okay, fine. And some addresses. And as I scroll down here, you know what disappoints me? I don't see any IP addresses. We're going to have to use a different tool for that. Let's go up to this IP whois lookup. This is dnschecker.org. Now, I apologize. You're going to probably see a bunch of advertising. Just ignore that, please, and try not to click on it. We could enter an IP address and do a lookup, but look at all of these tools down here. Reverse IP, ping. We could do name server, in other words, DNS lookups, all DNS lookups. We could do CNAME lookups. So we said, what's this alias for? We could check our own IP. We could ping by v6. We could do an IP location lookup. Let's try a couple of these, okay? Let's first of all just do a plain old DNS lookup. And if we just put in Microsoft.com, press enter. All right, here are a bunch of address records. Okay, so Microsoft.com has some plain old IPv4 records. No CNAMEs, no quad A's, not for the root, Microsoft.com. There is one email server, and then those DNS servers, again, hosted by them. Some of these things are really specific, so Microsoft.com as itself is not going to have service records or pointer records. I do see that there are text records, probably for anti-spam. Start of authority is on this DNS server. Okay, that's cool. Very good. Let's see what other kinds of tools we can use here. Why don't we go to all tools? I'm going to all tools here. I'm going to click that. There's DNS tools, IP tools, network tools, cybersecurity tools. Let's try IP tools. We're going to click that. We could ping by IPv4, by IPv6. What is my IP? We could trace. Let's trace. Let's do a trace route to Microsoft. Now, the first thing is, if you just say Microsoft, they probably have, like, as we saw, 4 or 5 addresses. Let's trace to a specific address. First, let's find a specific one. I'm going to go to ping IPv4. Click that. I'm going to put in www.microsoft.com, although there are probably a whole bunch of these as well. But let's just ping them just so we can get the IP. So we ping that. Let's get some results. Okay, so they do a bunch of pings against this particular IP. Let's just use this one IP here. Let's right-click, let's copy it. Let's go back up, and let's just hit the back button. I want a trace route to that IP right there. Click that. Trace route. Let me paste this in, and let's see what we go through to get to that IP. Give it a moment. It'll give us results in just a moment. We have some results here. Now realize that this is from these people right here, wherever these people happen to be. The first one, maybe their firewall, maybe their router, is not using ICMP. It's blocking ICMP. Now, most trace routes no longer just use ICMP. They usually use UDP because ICMP is blocked so much. But if a router or a firewall is configured to not use ICMP at all, it won't respond. Doesn't mean that packets aren't going through it. You can see packets are going through it. It's just not speaking ICMP. Usually that's a good hint that that's a firewall. I mean, it could be that it's a router that's way too busy to reply, but chances are even better that it's a firewall. So it looks like the first hop they went through, we don't know the IP address. It didn't tell us. It's probably a firewall. Okay. Then they're still in a private address range, which could be within their ISP or could be within them. Then we can see several hops they go through, and then several more until we finally get to this address. And look at this. This address right here is actually being hosted by a mirror. It has this big old long name. It's being hosted by Akamai, which is this mirror group. They have mirrors of everything everywhere. They're the group that actually knows where things physically are. So that www.microsoft.com, this is a mirror being hosted by somebody else. Let's go back. How about some network tools? Let's go to network tools. Check open network ports. Ooh, you know what? Let's try that. This is a port scanner. Huh, okay. How about let's do a port scan of scanme.nmap.org, and you can put in anything you like. And let's just scan for server ports. How about that? Just the common server ports. You could add more, I suppose, if you want. Let's just click Start. nmap.org makes this deliberately available, but please don't abuse it. Scroll down here. Okay, so SSH is open. HTTP is open. The others aren't responding. They're probably filtered by a firewall. But at least we found two common server ports that are open. How about any other tools? Let's go back to CyberSecurity tools. Oh, we could check the certificate. We could generate passwords. We could do a password strength checker. Oh, look at this. If you wanted to scan a QR code, that's cool. Or if you wanted to generate a QR code, if you wanted to generate a bunch of phony credit card data, or check if a credit card number is valid. Wow, this is some pretty interesting stuff here. Let's check the SSL certificate of, how about example.com? www.example.com. Is the certificate still good? Check it. And we can see here, you know what's interesting? The certificate was issued by DigiCert, okay. And it was successfully validated all the way up. All right, great. And then we can see some details about this. That's cool. Oh, the public key. You know, a certificate is just a public key on a document or on a file with a little metadata. Let's view the public key. So this is the public key of the certificate. Oh, that's really cool. Okay, so let's try the next one, the autonomous system numbers. Come over to autonomous system numbers. This is asnlookup.com. And I'd like to find out the ASN numbers, the autonomous system numbers of Microsoft. You know, you can get an autonomous system number if your organization has enough nodes. I believe the number is 50,000. If you have 50,000 IP addresses that you use, you can have your own ASN number. Let's click Look Up Microsoft. All of these ASNs. Even in China, Microsoft Mobile Alliance Internet Services Company. Okay, some UK, Microsoft China Company Limited. I wonder if that's actually the Bill Gates Microsoft. I wonder. Let's click that. Oh, I wonder if this is actually Microsoft in China. Interesting. Registered in AppNec. Okay. And here's their address block in China. Let's click that. So we can see information. Country, United States. It's looking more and more like this is Microsoft and not just some bogus Chinese name. So these are some of the things we can do when we're doing OSINT. We can start with classic whois, which we did here. We can check out various IP tools like DNS and security tools and network tools. We can even check out autonomous system numbers and get IP address blocks as well. There are many online tools like this, as well as ones that you can just download and run from your own machine. But whois type lookups are one of the first things you want to do when you're doing OSINT footprinting. Now let's move on. There's a lot of good information to be had from querying a DNS server. Now, what is DNS? DNS is a whole topic in itself. It's something you study in a networking class or a certain server class, and it's beyond the scope of this class to get too deep into it. But let's talk about what's important to us as hackers. Websites, servers, network devices, they use IP addresses, numbers. Humans aren't so good at remembering numbers, but we can remember names pretty well. So we assign friendly names to IP addresses. When we want to go to a website, we don't put in the URL, the IP address, we put in www.somewebsite.com. In the background, the client, your device, has to go and query a DNS server to find out, hey, I've got a name, can you give me an IP? And once the IP is found, then it can take you to that website. So let's talk about the DNS records that are useful. There's a lot of information to be had from DNS. We can use this to find key hosts on the target. The most basic type of record is the address record, the A record. That's the IPv4 address record. That's the I have a name, please give me a number. Or if we're talking IPv6, that's the quad A record, AAAA. I have a name, please give me the IPv6 address. Or there's the MX record, mail exchanger. I have a name, I need to know who the email server is. And once I know who the email server is, then give me the A record for them. Or there's the NS record, the name server, the DNS server. Who are the DNS servers for this particular domain? Or there's the CNAME record, canonical name, that's an alias, another name for the same A record. Or there's the start of authority, the SOA, not to be mistaken for SOB or SOL, right? But start of authority is the record written by the person who first starts this DNS domain, this zone. Then there's the SRV record, the service record. This contains information like logon servers are here, global catalog is there, PDC emulator is this. Active Directory, Microsoft's Active Directory uses SRV records a lot. They should be internal and not on the internet. Then there's the PTR record, the pointer record. This is the opposite of the A record. I have an IP, please give me the name. It's used for security. I can see that you are IP address so-and-so. What did you say your name was again? I'm just going to check you out. Then there's responsible person, or host info, or unstructured text. We use the text records a lot for things like anti-spamming. There are a ton of tools to query DNS. Some command line tools that are popular are NSLOOKUP and DIG and host. And then there are online sites and tools you can download as well. Here's an example using NSLOOKUP. We just want to NSLOOKUP www.hackthisSite.org. Okay, give us back the server IP, its address and port. And also, here is a non-authoritative answer, meaning I'm not the one that, as a DNS server, I'm not the one that actually holds the DNS zone, the database file, but I learned it from another DNS server. So here's an IP address that I learned, and here's another IP address that I learned. Here's an example of using dig in Linux. So we could just say dig some website, or we could say dig and then querying a particular DNS server, like I want to query the Google 8.8.8.8 to give me all A records for example.com, or give me the short version, or give me all the text records from them, or give me all the aliases for them, give me all the DNS servers for them, or give me all the email servers for them. And then, and you're going to need to know this, I could ask to transfer the entire zone, in other words, the database file for that particular domain. I could ask for an all transfer of this domain right here, and I'm asking this particular DNS server to give it to me. This DNS server, please give me a full zone transfer, all of the records in a text file of this particular domain. So that would be like a hacker requesting that. Only a legitimate DNS server should ask for an alt transfer, but you can do it manually using dig. Here's an example of just using an online DNS service, online DNS lookup. What's mydns.net? Then there's something called Sublister. Now, Sublister is a tool to find subdomains in a domain. You can install it in Kali. And the cool thing about finding the subdomains is, you've got the parent company, and we've talked about this before. You've got the parent company, and they probably have all the resources and the skill and the security necessary to protect their various resources, right? But you'll have all these little child domains that won't necessarily have the manpower or the skill or the technology or the resources to protect their records. If we can hack a child domain, like a website on a child domain, we might find a way to go up into the parent domain. Sublister is a tool we can install in Kali to try to find child domains of a larger domain. So here's an example here. We're trying to find child domains of comptia.org, and we found all of these. Now, some of these might be child domains, some might just be hosts, but they're trying to find things, whatever, .comptia.org. So that's Sublister. Finally, there are location search tools. One of the cool things when you're hacking is you're not going to necessarily do it all remotely. You might go there and dumpster dive, try to sit in the parking lot, set up a phony Wi-Fi access point. You might just sit there and observe people going in and out. You might go and sit in their lobby and try to plant some kind of device. We can use Google Maps, Google Earth, Wikimapia, Yahoo, Bing, National Geographic Maps. There are lots of services online that will allow us to visually look at from different angles the physical location of the target. So this is searching DNS and location. And now, on to the next topic. So NSLOOKUP has been around for a very long time. It is a Windows command, and on my host I have my command prompt open here. And I can just type NSLOOKUP. And right now you can see that my default DNS server happens to be this one of this particular address. And what I'm going to do is I'm going to just do a little bit of looking. I'm going to set type equals A. And in fact, let's back up just a bit here. If we just type a question mark and press enter, the question mark is simply asking for help. And you can see all of the help options here. And one of the things we can do is we can say set, and then we can set something. We could set like the type of record we're looking for, or we could set a server name, or we could set other things. If we come over here and we look, the A record here is an address record or a host record. So we just want host records. We don't want quad A, which are IPv6. We just want A, which is IPv4. So let's set type A. So that's the kind we're focused on. Set type equals A. Press enter. No acknowledgement, but no error either. And now let's go and query a domain called www.certifiedhacker.com. So we're going to say domain www.certifiedhacker.com here. So we're going to focus on the domain of www.certifiedhacker.com. Now you might say, whoa, www is not a domain name. That's true, but that's just the syntax. So when we say domain in this case, we're talking about within the scope of this name right here. So within the scope of this, let's press enter. And so we can see that the server is this, its address is this, and it is alias to this. What this means is certifiedhacker.com is the name of the server, but it has a CNAME, an alias, also known as www.certifiedhacker.com, because a lot of websites will have many names. They'll have a primary name and an IP address, and then they'll have all sorts of canonical names, CNAMEs. So speaking of that, let's set the type CNAME. Let's look up the aliases, the canonical names, the CNAMEs. Set type equals CNAME. So let's focus on those aliases. And let's find out about www.certifiedhacker.com. And so we can see right here that according to this DNS server available at this IP address, www.certifiedhacker.com has an alias or has another name, certifiedhacker.com. Now let's go the other way. Certifiedhacker.com, and we get information here. So we can see that certifiedhacker.com, actually, certifiedhacker.com itself has a primary DNS server called NS1. It's very, very common to name DNS servers NS something for name server something. .bluehost.com. Sounds like that's a hosting company maybe. And then there is a mail address, dnsadmin.box5331.bluehost.com. And then we can see that this serial number here is the serial number of a DNS record. If you've ever looked at the start of authority on a DNS server, every time the zone, the database of those records for that particular domain change, this serial number increments, letting the other DNS servers, the secondary servers, know that this is the latest version. And we can see that this thing is supposed to be updated in a day and retry every 2 hours if you can't reach your primary DNS server, your master. Expire this thing in 41 days and 16 hours if you just cannot update at all. And the time to live is 300 seconds, 5 minutes. So this is the default time to live, TTL, for any record in certifiedhacker.com. So now we've gotten some more information. Now let's find out what we can about nameserver1, bluehost.com. Let's set type equals A again, and let's find out about ns1.bluehost.com. Press enter. And so we can find out a little bit more about ns1bluehost.com. We already know that. So this is just some stuff we can do using the built-in Windows command nslookup to find out just online about records that are out there. Now, quite honestly, there are website versions of nslookup that are far more powerful than this, but it's always handy to have those command line commands. So that is using nslookup to query DNS. Let's now talk about footprinting websites. We're trying to find out information that will help us determine, can we hack into the website or the web app or modify data passing to and from that website. There are a number of tools we can use. Some of these are just on our own machine. Some are separate apps. Some are services. We use them to look for connection status, content type. When was it last modified? What's accepted? What powers it? What are the web server versions? We'll look at HTML source code, and we'll examine and validate cookies. When we're enumerating websites, we could use OSINT to discover additional information about that website. Let's look for personnel or host names or domain names, anything useful that might be exposed by that site or might expose information about those servers. We could, of course, do Google dorking. We've talked about that already. We can use Shodan, and we can use other things like Netcraft and LinkedIn and PGP key servers, many sites that might give us additional intel. We could search domain names and IP blocks. So here's a tool called SiteDigger. It searches Google's cache. You know, when you do a Google search, Google will cache the information. Like if there's a page, sometimes that page gets taken down, but you can look at the Google cache to see what it was before. This tool, SiteDigger, might help turn up vulnerabilities and errors and configuration problems, proprietary information, or any security nuggets on the websites we're going after. We've already seen how we can use information through Google dorking. A web spider is something that will automatically crawl all over the target website and collect information. The names, the titles, the addresses, the email, the phone, the fax numbers. People still use faxes? Anyway, and any meta tags. Web spiders help with footprinting and social engineering attacks, and there are a ton of web spidering tools. Here's a tool called DERB. It's a command line tool, and its whole purpose is to look for hidden web objects, as well as existing ones. It's really good in trying to find hidden web subdirectories. So, like, you can go to a website, and you'll find navigation links to go here and go there, and that content is usually stored in different directories. There are some directories that don't have specific direct navigation links, but they exist. So DERB will try to find them by using common dictionary names, not Joe and Bob, but names of typical website directories. And it'll see if it gets a response or not. Ah, these things actually exist. Okay. DERBuster is a GUI competitor to DERB. It's quite easy to use. We could just go and copy the whole website. We could do website mirroring. Just get an entire copy. Now, if you do that, that's really cool because you can take your time to examine the whole website offline. You know, if you are going to a website like 50,000 times, that might alert people. They might go, that's kind of weird. You know, the average person clicks maybe 20, 30 links on our site, and that's it, not 500. So we could mirror the site and then just crawl all over it ourselves, taking our time. The only thing is, if you are going to mirror a site, you need to copy very slowly because that too will set off their alarms. There are a number of website mirroring tools. Here are just a few. A place I love to go to is archive.org. They will regularly take snapshots of websites. Their storage must be bigger than the Library of Congress. They save cached copies, snapshots that you can browse and you can search for from when the website first appeared through time, like every month. What does it look like every month through all the years? You can find stuff that has been deleted. What did their website look like 2 years ago? Sometimes you can find original downloads. Not always, but sometimes you can get really lucky. Like I've done some searches for original copies of hacking tools before they got infected with viruses. Imagine a hacking tool infected with a virus. Yeah, it happens a lot. So you look for like the original ones, and I'll see people say, yeah, I found back in March of, 2003, this was the earliest one, it's an original. So they not only have snapshots through time of every website that they can crawl, but there's also a whole community of uploaded software and videos and music and documents and other kinds of like training documents. So archive.org, a really cool place to go. They are the ones who have the Wayback Machine. And you can see here all the different kinds of files that you can get. Here's an example here. Let's just look for CompTIA.org, and we can see over the years here, all of the different saves and changes of CompTIA.org. And we can go, oh, well, 2005 was the heyday, so let's go to 2005 and look at some of these where there was a lot more traffic and a lot more modifications, a lot more saving and changes. So archive.org, it's a great place to go. You can also subscribe to website monitoring, and I've talked about this in other scenarios. This monitoring will actively check web pages for updates, and it'll let you know. It'll send you alerts. Here are just some of the tools you can use for website update monitoring. So that's our look at doing OSINT just by crawling all over and searching websites and web servers and web pages. And now, on to the next topic. We're going to extract links, URLs, and emails from a website, and we're going to use Web Data Extractor. I've installed it on my Windows 10 machine. I'm going to launch it. Click New to start a project, and let's go after certifiedhacker.com. www.certifiedhacker.com. We want to get, all sorts of stuff here. URL, meta tags, emails, phones, faxes, who knows. Retrieval depth, let's go a couple down there. We're going to go to the main site, and then we'll follow a link, and we'll follow a link. Click OK. And then click Start, and let her rip. I'll let it run, and as soon as it's done, I'll come back, and we will analyze what we have. Looks like we're all done. Web Data Extractor has finished the session. You can check the extracted data using the correspondent pages. Okay. Let's go to meta tags, and we can see we have different URLs. That's cool. And there are different titles. There are keywords like real estate, booking a hotel, some descriptions. We'll scroll over. Now, this is the interesting part. The host, where this came from. You know, when you go to a website and you get content, a lot of that content, especially multimedia content, comes from a whole different server. We can see page size, last modified. All right, meta tags, good. Emails, looks like we have an email. We'll click that. Okay, there's an email there. Any phone numbers? Let's click that. Couple of phone numbers, great. Any faxes? Well, yeah, okay. People still send faxes. These are the fax machine numbers. Anything else? Nothing? URLs. Just general URLs. Now, this is good stuff. This is good stuff because sometimes you don't realize the subdomains or the other pages. Like, see these with the little hashtag in front? These are actually internal links on the same page. So this will lead us to other areas that we might miss. Anything inactive? No. Okay. I'd say this was successful. If you want, you can try it on some other websites. I'll see you in the next activity. Now, sometimes you want to copy an entire website, so you can take your time with the offline copy. Because, if you're crawling all over a website too much, they might get suspicious. Because it would be unusual to request every single page from a website. So what you can do is you can slowly copy a website and then use that offline copy to go through and search for all sorts of stuff. So if you want to do that, you can use httrack. There are actually a number of website copiers, but this is one of them, and I've got it on Server 2016. I did a simple default install. I'm just going to start it, double click it, start it, and we're going to pay attention to where it puts the stuff, and there's a little welcome, and I'm just going to click next, and I'm going to create a project name, and I'm going to call it copy certifiedhacker.com. Copy certifiedhacker.com. And it's going to go and see my websites in Server 2016. So let's pay attention to that. You can browse to put it somewhere else by clicking this little browse button, but I'm happy with the default. We'll click next. And you can either just type in the URL you want right here, or you can click add URL. If you click the add URL, it gives you the option also for username and password if necessary. So you can really go either way. I'm just going to type it right here, www.certifiedhacker.com. Hope I spelled that correctly. If I want to set any options, I can click set options. And I can, if it's FTP, I can use a proxy. I can set some scan rules to exclude certain types of files. I can set some limits on throughput, transfer rate, how deep I'm going to go. But I'm just going to go ahead and make it just the default. I'm not going to set any special options. So I'm copying www.certifiedhacker.com, clicking next, and just going ahead and clicking finish. And it may take a couple minutes because it's going to go grab the whole thing. You can see that it is going and grabbing. And if we didn't want to set off any alarms, we could have made it slower. But in our case, because this was set up specifically for us to practice with, and you can do this too, we'll just let it go at its default speed. So I'm going to pause the video because it will take a little bit. And when it's done, we're going to come back and see what we found. Okay, it's all done. Now, we're getting some flashing, this is cute, view error log. So it says mirroring operation complete. Click exit to quit. See log files if necessary to ensure that everything's okay. So I have this big old blinking view error log. Let's just click it and see. And it's saying, if we just expand this a little bit, that warnings and errors reported for this mirror. Note, HTS log text file and HTS cache folder may contain sensitive information, such as username, password, and authentication for websites mirrored in this project. Do not share these files, folders if you want information to remain private. Okay, so it's saying it has some not found 404 errors for a variety of things here, and I think that's fine. In our case, we don't really care. It says it took 1 minute and 33 seconds, 140 links scanned, 129 files written, and we received what looks like 2 megs, over 2 megabytes of data with some errors. So we have errors here that certain files were not found. I think we're okay with that. Now what we're going to do is we can browse the mirrored website. We can also just physically go out to the C drive as well. Let's click Browse Mirrored Website. And so what we're looking at here is an offline copy. This is your offline copy that you made. And you can see up here it's in the C drive, my website's copy. It is not the actual online website. So now we can slowly take our time with this. And we can just look at different things. It's asking for a login. We don't have one. We don't really care because we were just demonstrating something here. That's probably part of the problem, is that because we didn't provide a username and password, it's probably why we didn't see some stuff. So anyway, I encourage you to try this, but remember that if you do it to a website that is really big, it's going to take a long time. And also, you might consider having it go a little slower so that you don't get them angry with you. But that is capturing an offline copy of an entire website, or as far as we could go, using a website mirroring tool called httrack. We can also do footprinting using email. For one thing, we could search the email source header. Where did this thing really come from? It can reveal the address that sent the email message. We get a lot of spam or phishing that looks like it came from something known or legitimate, didn't really when you look at the header. We can see the sender's mail server, the authentication system for the mail server, the date and time of the message, the sender's name, maybe. We can also see, this was spoofed, or there are bogus links or phishing elements in this thing. Here's an example of examining an email source header. Okay, so it says club stores, but when we look here, info underscore some weird funky name at some weird funky.io, obviously created for a phishing campaign. And we can see that when we actually look at the HTML underneath. There are a lot of tools we can use to track email. When we track email, we can see who was it sent to, where did it go through, the geolocation, was it read, how long did it take for them to read it, were there any proxies used in this, any links, any OS or browser information, any forwarded email, or the type of device the recipient might have used. And here are the email tracking tools from Email Tracker Pro, and quite honestly, if you're looking at webmail, you can just put developer tools in like Google Chrome. Here's an example of using Email Tracker Pro, and it shows where the email went from here to here to here. Now, I'm just going to say something right now about these visual trace route type tools. They do not necessarily show the true physical location. What they do is they do searches for, I've got an IP address, let me see the name of that that's associated with that IP address, let me do a reverse whois to find out who is associated with the name, where are they located, where's the server. A lot of these places are actually just where something was registered, not the actual physical location of the server. So just be aware of that when you use any kind of visual trace route, any kind of email tracker that visually shows you how the email moves around. It won't necessarily show you geographically. It'll show what did it go through and where was that thing registered. So it could have been, the device could be a server in the Midwest US, but it was registered in the South. So just to be aware of that. But nonetheless, there's a lot of information to be had when we footprint using email. And now, on to the next topic. We're going to analyze a suspicious email that came in. We'll do some manual analysis first, and then we'll use Email Tracker Pro to analyze the header of the email, wade through all of the stuff for us. I have something that came in, and you can see it's pretty darn suspicious. Look at all of these little urgency things here. Your $24,300 settlement check has arrived today. Confirm now, please. Ding, 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 ding. Okay, first of all, where did this come from? info@wletwo.com to, well, this sure isn't my email address, who they sent it to. We expand this here, we can see all of this. This stuff here, this from, to, date, subject, you can fake all of this. This can all just be whatever you want, quite frankly. We can see that it was mailed by whoever, signed by, well, digital signatures don't really mean much. Okay. As I scroll down and just kind of move my mouse over it, I see this is a link right here. Settlement payment came in. And I'm just scrolling down. Okay, so this is text, and this is a link. Got to be really suspicious about clicking any links here. The email itself these days probably doesn't have anything malicious. It's when you click the link that it sends you to something malicious. Let's try to analyze that. Coming over to the upper right here of the message where it says more, and you have the three little dots, going to click that. And I'm going to look at Show Original. Click Show Original. And here, of course, is all that message front matter. Down here, this is the actual underlying text of the message. And if we scroll down, you can see delivered to and received from some IPv6 address. And I can see source, and I can see message signatures. I don't really care about that, quite honestly. I can see SMTP mail from some weird address here. You know, these spammers, they'll just stand up some weird address and sometimes stand up a weird SMTP server, blast out stuff, and then take it down so you can't trace them. And I can see a little bit more, some signatures. Really don't care about signatures. All the way down to these dotted lines here, that's the divider between the header information and the actual message. I want to look at the actual message under the hood. The very first thing we see is a link right here, and this makes me really suspicious. This is a link to a storage site in Google APIs. First one bucket 21. You know, you go to Amazon Web Services, you go to Google, you go to these online SaaS, PaaS, IaaS type providers, and you can just set up storage buckets. This is something that they named it, First One Bucket 21. They're sort of the equivalent of the modern day FTP site. They're just file shares, and they just put stuff in there. It's very common to just put marketing material and catalogs and things that people would legitimately download. It's common to put it in there. So it's clear that they're using a Google bucket, a storage bucket online for this content. But I'm really suspicious. So this is the item right here. This is the item that they've got in the bucket. So I'm really, really suspicious about that. And then, of course, here's all the text. Settlement payment came in due to involvement in a class action lawsuit. Go there now to accept what's reserved in your name. And they want me to, again, try to click this thing. I don't think so. Let's copy the header, this entire header, and we'll get Email Tracker Pro to wade through it and give us the analysis. Let's just copy this whole thing. With any luck, Email Tracker Pro has already grabbed it for us, but just in case. So I've highlighted the whole header up to the dotted lines. I'm going to right-click and copy, and I'm going to bring up Email Tracker Pro. The first thing you see in Email Tracker Pro is they say no email accounts have been set up an account. They want to be able to intercept all emails sent to one of your accounts and analyze them as they come in. We don't need that. We just want to trace one thing. So go to File and click Trace Headers. Click that. If they've already grabbed the content and filled it in, good. If they have not, we're just going to click, which should put in this message we just got. You don't even have to right-click paste. Just click, it puts it right in. We want to make sure that we have trace an email I have received selected. This is that whole setter, so you can even see the little ding, 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 your $24,300 settlement check, blah, blah, blah. This is the whole header, and it's in here right now. What we're going to do is we're going to click trace, and then we're going to watch that progress. Click trace, and then come over to my trace reports, and it's working on it. It's looking up locations, it's comparing IPs, it's comparing sources to what's in there. It'll take a moment or two. As soon as it's done, we will analyze its report. So I'm going to pause this for a moment, and then we'll be right back. Looks like the trace is complete. This came from Spain. Now, it doesn't necessarily mean that the perpetrator is from Spain. They could have just been using a provider in Spain. We can see all of the traces here, all of the IP addresses involved, all of the routers that were involved, the locations here that were involved. We do see that some of this is from Spain. However, when you go way back in history, we can see some of this goes through the US as well. Let me just scroll this over, or slide it over, so that we can read the email summary and the different summaries. Okay, so it came from whoever to, this is fake. The header analysis right here. Misdirected, yes, possibly spam. You could automatically generate an email abuse report. I don't think we're going to bother. This email contains misdirection. The sender has attempted to hide their IP. The sender claimed to be from qscsnatch.com, but a lookup on that name shows it couldn't be from the sender's IP. Scroll down a bit here. The sender system, no SMTP server running. It's a web server, Apache, so someone set up a Linux box to do this. No FTP server running. Okay. Let's find out about the network who is, and then the domain who is. The network who is, of course, information about the network this thing traversed. Let's click network who is. And we can see here that this is in Spain, and it is Dyna Hosting. Okay, the network name is DHJ3Net. So this is the hosting provider, Eladio Perez, but I don't expect this person in this location with this phone number to have actually sent the email. They're probably just hosting the service. Okay, so that's just the who is on the hosting service. Now, who registered the domain? Let's click this. Oh, nothing. There is no domain registration for this IP. Yeah, right. And then let's look at the email header, and that's the header that we pasted in. So, as we suspected, this thing is possibly spam, likely spam, and they were trying to hide their IP, which is what spammers do. Besides analyzing the header, when we looked at the source, we saw for ourselves that they're pointing to a storage bucket, and they want you to click something in this storage bucket. I think we will pass on that. Thank you very much. So that's how we can use a tool such as Email Tracker Pro to analyze headers and trace where potential spam came from. If you're going to remotely hack a site, it's good to know about the network that they're on and how to get to that network. So let's talk about network footprinting. First of all, we want to locate what public IPs do they use? What network ranges do they use? We want to map the target network. We want to find their network, their public network addresses, and we can look in the local regional internet registry, the RIR. We can do a who is search for that. Here are a couple places you can go, and here's one example of one of them. We can use command line tools, who is, curl. Now again, we're starting with looking for the public IPs and the public paths to get there. Once we get there, we need to find out their private IPs, but that's the next step. Here's another example in network who is. We're looking for Microsoft.com, and we see a bunch of addresses, and we're just doing on Domain Dossier a network who is lookup. Here's a command line version of a network who is. We're using the host command. So we would like to know about github.io. Okay, well, it has this address here. Or we can do it by address, and it gives us back the range of addresses as well as the network name and the country they're in. Or here's us using curl to find out something about a particular website or a particular domain. We're asking for IP addresses of GitHub, and then we want to just tease out, we want to grep for just IP range, and we want to then format it a certain way and sort it. And this is what we get out of it. So GitHub uses these ranges of addresses. Then there's traceroute. Traceroute will tell us what routers and firewalls are along the path to a target. On the internet, it's just going to be routers. But when you get to the target itself, the target network, you'll run into almost certainly a firewall, possibly a couple of firewalls. So we'd like to know the pathway along there, because sometimes one path might be a difficult way to get in because we run right into their front wall firewall, or their front door firewall, their main firewall. Well, is there another route where we can get in via some side door or some subdomain or some child site? So traceroute can be really useful as well. Traceroute uses ICMP or UDP with an increasing time to live to give us the name of the router, and here's how it works. And you learn this in a networking class. I will say, depending on the product, traceroute, tracert, Microsoft Trace, some destination. And what it'll do is it will either send a UDP packet or an ICMP echo request, but UDP is more subtle these days. It'll send one to the final destination, but the IP packet only has a time to live of 1. Now, if you study IP, you know that one of the fields in the IP header is the time to live. The time to live will tell us, okay, how many routers can this thing go through before the packet is discarded? That's to prevent packets from living on the internet forever if they're caught in a routing loop. So if we set it to 1, the very first router that it hits, probably your outbound router, will go, oh, time to live of 1. All routers, when they receive an IP packet, their job, among many things, is to decrement or decrease the number by 1 so that it keeps going down as routers. I send a packet to a destination, time to live of 1. My very first router goes, oh, 1, drop it to 0. 0 means it shouldn't go any farther. I will discard the packet and I will send you back usually an ICMP expired in transit message saying, hey, I discarded this thing and my name as a router is either my name or my IP address. Usually it's name, and then the traceroute tool will try to look up the IP address. So then you send another packet with a time to live of 2. So it gets past the first router, which drops it to 1, gets to the next router, which drops it to 0, discards the packet and says, hey, I had to expire this thing and my name is so-and-so. And you keep on going until you finally get to the destination. And actually, most trace tools don't send only 1 packet. They send like 3 at a time. 3 with a time to live of 1, 3 of 2, 3 of 3, etc., until you hit the firewall. In a trace route or a trace, when you start getting no responses, just asterisks, chances are you've hit a firewall, or you've hit a router that's so busy it doesn't have time to respond properly. That's the idea of traceroute. So we can use this to find an IP address of the target firewall, because ultimately we're going to get up to that point and go, oh, that's the IP address, okay. It helps us map the target network. And here's an example using traceroute, and we've gone through all of these. So the first one, we got a response, probably our own router, and then we have 3 stars here. Those stars could either be I'm too busy to respond, or I'm a firewall and I won't respond. But we get past that. And now we've got 3 more routers, and then there's another thing that's not responding. And then we get past that, etc. In some of these, you'll get the response from the name, and then you'll see the IP lookup. So this is traceroute. Very, very useful when you're trying to map how are we going to get to that target remotely. You can also do traceroutes using online tools. Here's an online traceroute example. So you can go to one of these places and do a trace to some location, and from them, not from you, from them they'll tell you how they got there. There are any number of traceroute tools. You can install these. Now, again, as I said with visual email trackers and visual traceroute tools, you have to be really careful about taking as read the pathway that it shows. Because again, a router might be physically in one location, but it was registered by AT&T, which is located, their headquarters is somewhere else. So you just have to be careful about that. You don't know for a fact that devices are in a specific physical location. But what is useful is to know the logical path. That's the important part that we care about. So that is using, whoops, okay, sorry. I forgot what the topic was. So that is doing network open source intelligence. And now, let's move on to the next topic. There's also a lot of information to be had from social networking sites, and social media. Let's talk about some of that. For the sites, we could use social networking sites to gain important or sensitive data about targets. We could create fake profiles as an attacker to use these sites or use social media to try to lure the target, extract vulnerable information, get them to trust us. Employees are likely to post things like their job information, what are they doing, date of birth, their educational and employment background, names of spouse, kids, pets, which are often used as passwords. We could get information about the company, potential clients, business partners, trade secrets. What websites do they have? Upcoming news, mergers, acquisitions. Common social networking sites, you can list them, and there's a ton of them, right? I'm just listing a few of them here. What can we get from them? Where are you? What's your present activity? What are you doing? Give us info about your company, all the contact details about you, including photos, family and friends, information about property, banking details, background and criminal checks. We can get this stuff. We can also do people searches. Now, a lot of law enforcement and private investigators, they'll do people searches, but we can, as hackers, use that as well. It's a great source of personal and organizational information. What's your street address, your email address, your phone number? Let's see satellite photos of your residence. Date of birth. Let's take a look at pictures of you. Look at your social networking profiles. Find information about everyone around you. What are your hobbies and your current activities? What are you blogging about? Or work information, like where are you traveling? Projects you're working on, your operating environment. Now, there are a ton of people search sites we can use that are going to give us some information. A lot of them will want to charge you a little bit of money. I found that if you're really, really persistent, you can sometimes find the information you want just by constantly just searching Google and using Google Dorks, as opposed to paying $3.99 or $3.99, $2.99 for a particular report from a people search site. And as part really of the social networking sites, there are the social media groups, the forums, the blogs, where people post what they're doing constantly. They'll do it on Facebook and Twitter, and there are other places as well that are specifically forums and blogs and that sort of thing. These sites are actually being used quite a bit for disinformation by foreign adversaries, to influence political activities, influence elections, to fake shape public opinion. Oh, it looks like everybody cares about this. Well, no, that was several thousand fake accounts using bots, making it look like this is trending, and it's not really, but we're trying to influence public discourse. So we can use these social media sites and networking sites and groups and forums and whatever to try to cultivate a relationship with the target. Probably create a fake profile, try to join the group, start engaging them. If you're just trying to do a disinformation campaign, you'll use a bot to automatically post. And one of my hobbies is to track the templates that these bots use. So it's like little variations on the same theme, and you know it's a fake right there. They'll use it to automatically post huge volumes about some topic, even though it's all fake. Try to increase visibility, try to give malicious information visibility and traction, try to make an opinion or an idea seem to be popular. So there's a lot of footprinting we can do, and some of it is active engagement, but a lot of information we can get and influence using social networking sites. And now, let's go on to the next topic. Are there any countermeasures we can take against footprinting and reconnaissance? It's actually difficult, but there are some things we can do. The very first thing you need to realize is be cautious. When something gets on the internet, it probably will never fully disappear. And just realize that. Perform OSINT on yourself regularly to see what's out there. Identify information that might be harmful, and if possible, go to the sites that publish that information, try to remove it. Delete or deactivate unnecessary social media profiles. Use an identity protection service. Use Shodan and Google Dorks to search for exposed files and devices, and if you discover them, try to implement protective measures like delete things or shore them up or patch them. Conduct only private dialogues. Try to avoid public communication on forums and other sites. Keep a close eye on web pages and portals that you visit. Some of them might ask for too much information, like name, phone number, real address. Use different nicknames on the internet. It'll make it harder to find you. Switch your profile to private mode if the social network allows you to do that. And when you're adding friends in social media, only add people that you actually know in real life. These are the measures we can take to protect ourselves from footprinting and reconnaissance. Let's review the key points of footprinting and reconnaissance. In footprinting, you are gathering as much information as possible about a target in advance of the attack. You're looking for any information that might help you break into the target network. Now, you can do passive or active footprinting, but whichever one you do, you're going to be subtle or unnoticeable. If you are actively engaging the target, it's going to be in a very limited, very non-suspicious way. Small, random, seemingly unimportant details here and there, you can put them together to paint a bigger picture. Or detail might be something that you need later on in your hacking efforts. Research sources can include search engines and whois and websites, social media, social networking sites and job boards, press releases, advanced online services, DNS, email, competitive intelligence sites, and some social engineering, like just gathering business cards or something at a trade show. OSINT is the use of publicly available tools and information. So you scour the internet for stuff that's already out there about your target. You could use advanced Google searches using specialized strings called dorks. These are strings with advanced operators. The Google Hacking Database will list popular dorks that have already been created by the community. Whois is a protocol for searching domain registration information. You can use dig, NSLOOKUP, and a variety of tools to query a DNS server for host information. You can footprint websites by using spiders. They'll crawl through a website looking for specific things, like email addresses or phone numbers. You could mirror the whole site so you can take time with it, examining an offline copy later. Do it slowly at your own pace. You could use tools like Derb and Derbuster to try to uncover hidden subdirectories on a website. Google Cache and archive.org maintain snapshots of websites from before, over time, especially archive.org. You can examine email headers and use email tracking to identify the actual source of an email. You could use Whois, Traceroute, other tools to identify IP blocks, firewall IP addresses, and network available points of entry into the target. And social networking sites and social media, they will give you a ton of information, especially for social engineering. And that's our look at footprinting and reconnaissance. Now we'll move on.